In this video, I want to talk about thermal expansion, which is a concept from thermodynamics. So to get us started, consider this object right here. So this object we're going to classify as one-dimensional, and it's also going to be a metal. Now, I pose you a question. What would happen if we introduce heat into this system? So, to explore this question, I recommend we look at things microscopically. That is, we look at what happens to the individual atoms when we introduce heat into the macroscopic metal. Okay, so when you zoom in to the metal, you'll probably see some form of a lattice structure. So I want you to ignore the H's. These are hydrogen atoms, but for the sake of the video and the lesson, just consider them some type of atom of a metal, right? So when we introduce energy as the in the form of heat, it actually becomes the kinetic energy of the atoms. So, and remember, kinetic energy is the energy of movement. So these atoms will begin to move around. So what does that look like? Well, it looks like this. So as you can see, the atoms will move. Specifically, they will vibrate and jostle around from their equilibrium positions. But I think more importantly, I want you to consider the lines, the orange lines. So those orange lines actually are supposed to represent the bonds between the individual atoms. So what can we see? Like if you just focus on this one right here, the bottom, the bottom left, you can see that it gets stretched, right? The bonds are stretched as a result of the movement of the atoms, which came from the heat. And that's just what happens microscopically. We can then make the assumption that if every bond of every atom is stretched, macroscopically, we can make the conclusion that the whole metal is being stretched as well. So that's why it's called thermal expansion. So if we introduce heat into the system, this metal right here will grow if you have some original length L naught, it will grow by some length delta L to to a new length, just L. So this behavior is actually modeled by an equation. So the change in the length is equal to alpha. So alpha is called the thermal the thermal coefficient, and it's largely dependent on the type of metal you're dealing with. So the thermal coefficient of silver is different from gold or iron or any other type of metal. So yeah, you can usually just look this one up, and it's so yeah, you multiply. So yeah, the change in uh, length is equal to alpha times the original length times the change in temperature experienced by the system right here. Now, what's really good is that you can also extrapolate this formula to higher dimensions. So if you want to so you want to find the change in volume, for instance, of I don't know, of a 3D system like this, it could be, so yeah, the change in volume will then equal beta this time, and the initial volume, and the change in temperature. You might be wondering, oh, what is beta? Beta is approximately 3 times alpha. And that's about it for thermal expansion.